Hey everybody! The purpose of this video is to get you some solutions to the Monty Hall extension quiz. So in the first one you've got 4 doors. Your job is to pick a door, and then Monty shows you 2 doors with nothing behind them, and then he offers you the choice to switch. So we need to pick a door first. Jessica, door from 1 to 4?
3.
Door number 3. Okay, door number 3 it is. So we're going to put a little J next to door number 3. She gets to pick that door. So the first question you ask is, what's the chance she got the prize? Only one prize, 4 doors. So what's the chance she got the prize? Yes, 25%. And the thing about it is that all of the doors, no matter which one you picked, or she had picked, excuse me, would have been 25% likely. So the problem is, you're probably wrong with whatever door you picked. You're only going to be right 1 time out of 4 on average. So now what Monty does is he's going to crack open 2 doors that are empty. Okay, he's going to open 2 doors that are empty. Let's see how good my art skill is. Let's open door number 1. Okay. And door number 2. Okay. Now, those doors are open. There's nothing behind them, which means they are not 25% likely to have a prize behind them. They are 0% likely to have a prize behind them. This one too. But that 25% has to go somewhere. So where does it have to go? And this goes back to what we talked about in class. Your door is still 25% likely. The prize didn't move. So since these doors have no likelihood of having a prize behind them, and yours stays at 25, that means this one right here has to be 75. Which means if you switch, you want to switch? She doesn't want to switch. She's going to stay with her door. Of course, it's a chalkboard, so I can't actually open the board and see if there's a prize. However, she's only going to be right 1 time in 4 on average. So she should switch, because 3 times out of 4, she's going to be correct if she switches, and the prize will be back here. 3 times out of 4. Cool so far? Cool so far. Now, part 2 was just an extension of that to drive the point home with 10 doors. Instead of 4. It's exactly the same logic. Jessica, pick a door 1 to 10.
7.
Door number 7. Now, her door, what's the chance she's actually correct on that door? It's got to be 10%. But they're all 10%. She randomly picked the door. The prize is randomly assigned behind one of the doors. So it's only 10% likely for each one. Which means there's a 90% chance it's somewhere else. Somewhere else being one of the other 9 doors. So then what Monty does is he starts opening doors, seemingly at random, but not really, because he knows where the prize is. So let's say he opens door number 1. Now that door, which was 10% likely, is now 0% likely. Its 10% has now been shifted over to all the other doors. He opens door number 2, say. That 10% shifts back to all the other doors, except yours. Yours is still only 10% likely, okay? Everything keeps opening doors, skips door number 4, we'll come back to that. Phenomenal artwork, yes? Yes. Okay, boom, 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 boom. He opens 8 other doors. Now, none of those have a prize behind him. Jessica's door is only 10% likely. That forces door number 4, or whatever door he opens, to be 90% likely. You want to switch?
Yes.
She wants to switch this time. 9 to 1 odds says she made the right choice. There's only a 1 in 10 chance the prize was here. There's a 90% chance the prize was here. Now, I think you guys actually bought it by that point in class too, but I wanted to make sure that you remembered it. Okay, now this was the one that almost got me beat up when we talked about it. So, back to question number 1. 4 doors. Jessica, pick a door.
1.
Door number 1 this time. Okay. What's the chance she's right? Jessica! 25%. Which means these are all 25% likely. But this time, Monty only opens 1 door. Door number 3. And it's empty. Which means this is 25% likely, and these 2 doors are 25% likely. And he stops opening doors. And you look at him, and you say, why would you stop opening doors? And he says, because, I don't know what he says, I'm making this up right now. But you have to decide, will you switch or not? Will you switch or not, knowing this? Jessica, will you switch? Or will you stay with door number 1?
I'll switch to 4.
Switch to 4! what's the chance Jessica's right if she switches to 4? And that's the whole point of the question. What's the probability if you switch? What's the chance the price is going to be there? Okay, so here's the deal. It's 75% likely that the prize is either behind door number 2 or door number 4. How did you pick door number 4, just out of curiosity?
I have no idea.
No idea. Flip the coin in your head, essentially. Just guessed. Door number 2, door number 4. I don't know, pick a number 4. Flipping a coin in your head, right? So half the time, you're going to pick door number 4, half the time you're going to pick door number 2. In an ideal world where human beings are random, which is not the world we live in. But if you're choosing it randomly, that's going to be the way it is. It's a 75% chance the prize is here. But you're only going to guess it right half the time. Which means the 75% chance must be split between the 2 doors. So you're going to have a 37.5% chance here and a 37.5% chance here. So switching was definitely smarter because it's definitely more likely to win if you switch than if you stay. But it's not as impressive as up here when you had 3-to-1 odds in favor of you switching. Here it's like, I don't know, 10-to-9 odds or something. I can't do that math in my head. So, yeah, it's still better to switch. It'll always be better to switch as long as he opens at least 1 door. It's just that the fewer doors he opens, the worse your odds are better. That doesn't even make any sense. Your odds are always going to be above 1-to-1, but they'll be more impressive if he opens more doors. Play, what you got?
I said it's 3-to-2.
3-to-2, 3-to-2, it's 3/8 to 4/8. Oh, I guess it is, isn't it? Or 3/8, so yeah. 3-to-2. Thank you, Jessica, for doing the math for me. Not as impressive as 3. Not as impressive as 3-to-1. It's Friday, give me a break. So anyway, that's an analysis of your Monty Hall extension quiz. Please don't kill me next time you want to try it. Thanks. See you in class.